Welcome to my Fanuc Roboguide tutorial channel. This is a multi-view vision process tutorial video. If you want to learn the basic for Roboguide and fixed camera vision process, please refer to link in the description. From the basic tutorial video, create the new work cell accordingly. Use the default selection robot to continue the creation wizard. Search IRVision and then select the IRVision 2D package and IRVision 2DV. Prepare the work cell accordingly. Now, add the base plate for our robot. Remember to change robot height according to base plate thickness. We need to reserve some space for the camera to mount on robot end of effector, so, select Add Link from the UT1 and then select Box. After that, set the size and location. Tune the size of box slightly bigger than the flange. Add link at UT1 again and then select CAD library. From the menu list, select pointer. Change the location of the pointer CAD to attach at the end of the box. Now, enable the vision simulation from the vision menu at the cell browser. Right-click to change the properties. After controller rebooted, go to UT1 again and right-click. Select Add Vision Sensor Unit option, and then, Add 2D Camera and then CAD Library. Select the same camera. Move the camera CAD to correct orientation with the triad. Round off the imperfect values and then move the camera to near to the position we want. Use the measurement tool to move the camera to attach to the EOHE link. Add fixture to the work cell with the fixture menu at the cell browser. From the CAD library menu, select Table menu and then select the table accordingly. Change the table location and size now. The size of the table was setting with the scale value. We have to measure the table actual size ourselves so that the location of table center can put nicely at the covered range of the robot working zone. Now, set the location coordinates of table to center of robot. Add the calibration jig as part to the table and then locate it to the top surface of table. Add another part to the work cell with box. Then change the name to glass panel. Set the size accordingly. Double-click at the table and then select Part tab to add part. First, set the calibration jig to slightly higher than the tabletop. Then move it to Robot Camera View Center. We can check the camera view with the View menu bar and then select Camera View. Now, go to the cell browser and then select the Vision menu. With the General tab, click the port 1 and then select Device to map to it. From the top menu bar, select Robots menu and then select Internet Explorer option. Click the Vision Setup button and then create the camera data. Set the camera and then choose Yes for Robot Mounted Camera option. Then change the calibration option method to grid pattern calibration. Temporarily save the data. Now move back to the Roboguide screen. Now, open the camera properties from the UT1, and then select the Setting tab. I do like to change the focal distance to 16 mm for more detail image. After that, go to View tab and change size to 1250 mm, and then, visible setting to only when snap is done. Open the Teach pendant and click a menu button. Select IRVision option and then select IRVision utility. From the utility screen, choose the automatic grid frame set. Set the group number as 1, and then remain the user frame and user tool number as we are using the empty frame. Change the camera name to the camera we connected to robot earlier. After that, change the grid spacing value to 30 mm. Record the current position as start position. If we need to confirm the current recorded position can fully view the calibration jig, click the Display Image button on Teach pendant screen and click Find button to check the image result. After confirm all settings, move away cursor from start position setting, hold down Shift button and then click Execute button. If we found the alarm as position not reachable or axis limit, we need to reduce the WPR angle limit. Reset the alarm and move robot back to start position then execute again. When dialog showed, select Restart to continue. Robot will move for 14 procedures to confirm the center point of calibration jig and camera center point. After completed of procedures, user frame and user tool data will overwrite by robot automatically. Now, please copy UT1 setting and then paste at UT2 as we need UT2 to set the tool center point at sharp tip. Change the UT2 tool center point accordingly. Open the Internet Explorer again, and then, click Edit button to enter the camera data. Go to Calibration tab and set the parameters accordingly. Move the square to cover as much as the full circle dot. Now, our calibration was completed. Don't forget to save it. We can check the calibration result at the Calibration Result tab. Now, back to Roboguide, add the glass panel to the table fixture. Set the location accordingly. Create a program and follow my step to add on the instruction. If you could not follow, please have a view on my basic tutorial video. After done from creating program and home position, please back to Internet Explorer and click Create button. Select 2D multi-view vision process from the list. Input a name for the vision process. At the 2D multi-view vision process menu, set the offset mode and offset frame. Others item please remain and will set up later. Go to camera view 1 and set the camera data we created and calibrated just now. Repeat the same thing to camera view 2 and 3. Move selector cursor to 2D multi-view vision process menu and then click Add button and then add camera view 3. Default vision process for camera view is using GPM locator tool. But our workpiece is not suitable to use this tool. Please delete all camera view GPM locator tool. Now, select the camera view 1 and then click Add button. Select combination locator tool from the list and then click OK. Repeat this step for camera view 2 and 3. Back to Roboguide screen, go to View menu at top menu bar and select Camera View from the list. Switch to top view of workcell, then click at the Teach Tool selection button to show the jog triad. Move the triad to the top left corner of the workpieces. After that, turn on the Teach pendant and confirm the user tool number and user frame number are in correct number, and then, record the first snap position in the program we created just now. Repeat this step to bottom left corner and bottom right corner of the workpiece. Please make sure you make some reserve lines at the bottom of the snapping points. After completed the position touch-up, move the robot to with the program to first snapping point. Open the Internet Explorer again and then select the camera view 1. Click the snap button to update the image. Then, select the line locator tool 1. Click the Teach button at the list below. Drag the line to one of the edge of the workpiece and align it nicely. Click OK to complete the teaching and continue. Select line locator tool 2. Drag the line to another edge of the workpiece image. And then click OK. Now, click at the Position Calculation tool 1. Set the locator 1 and locator 2 to the line locator tool number. After that, click at the Combination tool 1 and then click Snap plus Fine button to verify the teaching. After complete View 1, select Camera View 2. Back to Roboguide, open Teach pendant again and move to the second snapping point. At the Combination Locator tool to apply the same method from previous setup and continue to Combination tool 3. Repeat the steps again at Combination tool 3. After completed all locator tool teaching, click at 2D multi-view vision process. Click Find button if all 3 images showed on left. Find result success, click the Set button at the reference position status, and then, save the data. Back to Roboguide. Go to Cell Browser menu and expand the Part menu. Right-click at Glass Panel and then select Draw Feature option from the list. Click Headline from the pop-out toolbar, and then start to plot the path on workpiece at Part Track. Double-click at the end of Edge to complete the path plotting. Confirm the path at the correct edge. Now, move the view to the front of the table. We found that the orientation of triad created by the Draw feature does not match to Robot Tool orientation. So, please select Position Defaults tab, and change the normal to surface, and along the segment accordingly. Turn on the Teach Tool selection of User Tool number 2 orientation to reconfirm again. Now, go to General tab of the feature number 1, change the User 2 to User Tool number 2, and then click Generate Feature TP Program. Now, we can see the generated program showed in the Teach pendant. Open main program to add on camera snap instruction for each point. After done 3-point snap instruction, use get offset instruction to calculate the offset position of the latest image. Continue to input the program accordingly. Create the error branch label when the vision failed to detect the workpieces. Now, we modify the generated program from Roboguide. Insert the vision offset condition instruction, and then add additional motion instruction of vision offset at every single point. Back to main program, and then, add the home position after the path motion. Remember to change the user till number to 1 as home position is using user till number 1. Now, we can try out our program, with click Run button at top icon bar. After tryout without offset the workpieces, now manual adjust the R orientation of the glass panel. Then test out the program again. Carefully monitor the TCP path lines. This kind of application is suitable for glue dispensing system and also edge deburring system. Please try your best to learn. Thanks for watching, and see you next time.